Hello and welcome to this edition of Hanging Out with Red Hat Storage. I'm your host, Colleen Carisse. Today we have a really exciting topic to discuss, Red Hat Ceph Storage 2.3. To that end, joining me are two of my esteemed colleagues on the technical side, Daniel Messer and Kyle Bader. Daniel and Kyle, why don't you both give a quick introduction for our listeners?
Sure. Hey guys, I'm Daniel Messer, based out of Stuttgart, Germany. I'm the technical marketing manager for all the storage products in Red Hat.
And I'm Kyle Bader. I'm a senior solutions architect. I work with Daniels, and I'm in Southern California.
Excellent. Thanks so much, both of you, Daniel and Kyle. We're really glad to have you here today. Let's jump right into today's news so our listeners can better understand what exactly Red Hat just announced about Red Hat Ceph Storage. Could one of you summarize what's new in version 2.3 and at a high level explain how those features are addressing what our customers require?
Yeah,
Sure.
Of course. Oh, go ahead.
Right. I think it's safe to say that, as usual, with every release we incorporate a lot of bug fixes, incremental changes, and improvements. But there are three main features that really stand out. So the first is Ceph in containers is now supported in production. The NFS gateway for RGW has transitioned from tech preview to supported in production. And we have S3A compatibility with the Rados gateway as well now.
Well, excellent. Thanks, Daniel. That certainly sounds simple enough, but let's dive a little deeper to better understand those new capabilities. Daniel, what exactly is meant by NFS interface and why is it important?
So the NFS interface basically gives you access via NFS v4 to data that's actually stored in RGW via S3. So what happens is there's a lightweight protocol translation happening in front of the RGW using a component known as NFS Ganesha. So we use that also in the cluster space, but in this instance, NFS Ganesha actually uses the same library, so the same code path that the Rados gateway uses in order to store data in the Ceph cluster, and it exposes this data and then as an NFS v4 mount. So there's some translation happening. So folders in NFS become buckets in RGW. Files in those folders become objects in buckets in RGW. And there's the same translation happening in the Amazon S3 compliant way, where you have dividers in your file names and they extend the default system hierarchy. So the same would happen with NFS v4. Internally in NFS Ganesha, it's implemented as a file system abstraction layer, and it gives you pretty much a native access to the object store as an NFS v4 file system mount. There are some limitations, so basically you can read and write data and you can mount it as you are used to, but you can, for instance, not override random parts of a file, nor can you append parts to an existing file. There are also no NFS v4 ACL supported, and we, as of today, do not support links or symlinks with that. But apart from that, it's actually pretty straightforward NFS. We use auth authentication layer, so you authenticate against the Unix domain accounts present on the system that runs this part of RGW. And it's really simple in its implementation. It's not a caching layer like other solutions. It's really an on-demand protocol translation with no additional semantics, exposing the same data in both the object and the file access interface.
Interesting. So what does it mean that users can now access the same data set from both object and file interfaces? In other words, how significant is that?
There are a couple of interesting new use cases we can address this to, and that customers have actually asked us for a longer period of time. So the first is quite obvious. When you're transitioning from the legacy storage world to the modern, close to the application object-based storage world, you need some sort of migration path, right? So typically what you do is some sort of import. With the NFS v4 capability of the Rados gateway, this basically becomes a bulk file import through the NFS export, and when that's done, your data sits safe and sound in the object store. And in the same fashion, you can generally transition legacy applications that just use file-based access today to something that uses object-based access tomorrow, and they will still be operating on the same data set. On a more higher level to think about this is probably in terms of a multi-protocol workflow. So you have some workflow where at the beginning you build some artifacts. This could be, log files, software build artifacts, or some sort of media. And the tools that generate these data are, still file-based, and they're not about to change tomorrow. So you kind of change them. In this case, you can use NFS v4 to actually store these files, but then the consuming end of that workflow would actually be able to access this data via a native object storage interface using the S3 API. And that gives you more flexibility and while still using the same storage technology underneath. And last but not least, if you have Ceph, but not Gluster, but you still want to do file-based backups, this also becomes a use case now.
Interesting. Well, this kind of begs another question. What about validation with the Hadoop S3A file system client? Kyle, is this another way of saying that we're Hadoop ready, or is this just the beginning of maybe some new capabilities coming from Red Hat in this domain?
Yeah, good question. The work we've been doing with the tools in the Hadoop ecosystem, particularly the S3A driver, but also some other tools, is on a functional level, right? So looking at the Hadoop S3A file system connector and validating that it works with our dialect of Amazon S3, making sure that all of the different types of requests that can be made to an S3 store that are necessary for this sort of file system interface, making sure that they work. And that's kind of what we've done initially. We have a bunch of work planned here. So this is, like you said, you hit the nail on the head. It's really kind of the beginning of us really diving into these sorts of workloads for data-driven applications.
It's interesting, today in storage, containers is a really big topic. It's kind of a buzzword these days. Kyle, what exactly is meant by containerization for Ceph, and why is that important as well?
Well, containerization in general is a trend, right? We're moving towards an environment where everything is running in containers. And if you talk at the big hyperscalers, the Googles, the Facebook, that includes their storage components. And we were seeing that demand from customers as well. They want to run their storage components, and when they're using Ceph, they want the Ceph running in containers. So that's what we've done. We've done work to package and build build a build pipeline for generating Ceph-based Docker containers, and also the workflows around deploying containerized Ceph and getting that up and running.
Excellent. So Daniel, would you say that this means that we're suggesting Ceph for containers instead of Gluster?
No, not really. I think the best way to think about this is to make a distinction between storage in containers and storage for containers. So what we are announcing with Red Hat Ceph Storage 2.3 is storage in containers. Containerized Ceph daemons, or basically a monolithic binary or monolithic image that runs several daemons on demand. This is really, as Kyle explained, something that follows an ongoing trend about deploying everything in containers. And it makes sense because containers are fairly easy to deploy, are fairly easy to replace. It becomes easy to update software when it's deployed in a containerized fashion. And people have been started to adopt this theme, especially in the space where you deploy very, very complex distributed applications. So we have seen an ongoing trend around deploying actually OpenStack in containers and have that managed by Kubernetes. And now with Ceph in containers, this kind of completes the picture of the two going hand in hand together in a containerized format. So making Ceph available in containers is just a logical step to help with these kind of provisioning trends and ease a little bit of the pain of getting the software up and running. Now, storage for containers on the other side is a whole different story, right? We have a very precise strategy how we want to provide storage for containers as part of our productized Kubernetes offering known as OpenShift Container Platform. There, the road forward is clearly Gluster. So our container native storage strategy is Gluster based, and we want to make that an out-of-the-box offering. So it's not just enough to containerize your storage software, you also need to properly connect it to the consuming side, and you also need to be able to make that an integrated experience. So that's what we are aiming for. In the long term, when people install OpenShift, they shall get Gluster-based container native storage out of the box. So wherever they choose to deploy OpenShift Container Platform on, they don't need to worry about where to get the storage from because it's already integrated. It comes out of the box with the product. And in order to make that happen, you have to pack in a lot of additional things like a setup routine that uses OpenShift's native orchestration mechanism to stand up the storage environment. You need to have a capable connector. And in the end, Gluster is file-based storage, and that's exactly what containers need, right? Containers consume storage in terms of bind-mounted volumes from the host, and all the container resource specification interfaces talk about file-based storage, and that is what Gluster provides, right? And compared to all other storage providers, it actually provides this as shared storage, so you can use it with more than one container at once. So there's a clear distinction between storage in containers, which makes sense, and we did that now with Ceph, and storage for containers, which is our container native storage strategy.
Excellent points of clarification. Thank you so much. I want to thank you both, Daniel and Kyle, for joining us today. And on behalf of all my colleagues in Red Hat Storage, thank you listeners for joining us as well. Until next time.